A lumberjack of mass 98 kilograms is standing at rest on one end of a floating log whose mass is 230 kilograms that is also at rest. The lumberjack runs to the other end of the log, attaining a velocity of 3.6 meters per second relative to the shore, and then hops onto an identical floating log that is initially at rest. Neglect any friction or resistance between the logs and the water. A. What is the velocity of the first log just before the lumberjack jumps off? And B. Determine the velocity of the second log if the lumberjack comes to rest on it. So we're going to separate those into three parts: man, log 1, and log 2. I'm just going to write down all the information we have from the problem. Their masses. All their initial velocities are 0 meters per second. Mass final velocity is 3.6. And we're looking for the final velocities of the two logs. To do this, we're going to use the law of conservation of momentum, which states that unless there's any force acting outside the system, then that means the momentum at the start should equal the momentum at the end of the system. P equals mv, momentum equals mass times velocity. So we're going to find the momentum of the man, the final momentum, and we're going to use that to find the final momentum of the log 1. If we plug in all the numbers, it's just simple algebra, and we find the velocity final of log 1 is equal to 1.5 meters per second. That's the answer to A. And now we're going to use the same equation to find the velocity of log 2. Just plug in the numbers we know. Now the reason why we're not only using the mass of log 2, also the man's mass, is because the man came to rest on log 2. So we have to take into account the added masses of both the man and the log. So the answer here is going to be different. It's going to be 1.1 meters per second, and that's the answer to B.